it?
It absolutely is.
If that intended idea, whatever it is, fails to transfer from one mind to another, well, the whole learning system just stalls right there at the start,
Completely.
grinds to a halt.
So we need to move past just the casual idea of communication, like chatting. We need to look at its systematic definition, its purpose in a learning context.
Exactly. You know, in its general academic sense, communication is usually defined as the exchange of ideas or thought or knowledge between at least two people.
Okay.
But there's almost always an underlying intention there, an intention to change the behavior of the decoder, that's the receiver.
So it's about influence, not just swapping information.
Fundamentally, yes. But when you frame it instructionally, the stakes get much higher, much more specific.
How so?
Instructional communication is defined as the totality of the teacher's efforts, everything they do.
The totality. Yeah.
Yeah, it encompasses every single move they make to ensure that those stated instructional objectives, the learning goals, are actually accomplished.
Okay, and how do they do that?
Through the effective manipulation, and that word manipulation is used deliberately here, it means conscious control of 5 critical variables.
5 variables. Okay, what are they?
The task, which is what's being learned. The method, or methods, how it's presented. The media, the tools being used. The learners themselves, the audience. And the entire teaching learning environment.
So it's this active, ongoing process of managing all those pieces.
Exactly. Constant management and control.
That really paints the teacher or the instructional designer as the ultimate system operator, doesn't it?
It does. They're designing and running the system.
And to maintain that control, that totality of effort, you have to be absolutely fluent in the 6 essential elements that act as the variables within that communication process.
That's right. These are the core components.
And the idea is, if one of them fails, the whole system can potentially fail.
That's the system view, yes. Okay, so the first element is the sender, or the encoder.
The initiator, usually the teacher in a classroom setting.
Typically, yes. And their effectiveness really hinges on a couple of requirements that sometimes get overlooked. First, how they deliver the content. It really needs to follow the famous KISS principle.
Keep it short and simple.
Keep it short and simple. Brevity, simplicity, they're critical because complexity just ramps up the chances of misunderstanding. It introduces noise into the system very quickly.
Makes sense. What's the second requirement for the sender?
The second is that the sender must actively secure feedback. It's not a passive thing where you just hope it comes back.
Right, you have to seek it out.
You have to build mechanisms for it. And, equally important, be deeply mindful of their own attitude.
Attitude? You mean like being friendly?
Exactly. If the sender projects warmth, friendliness, approachability, it inherently helps motivate the receiver, the learner.
And the opposite is true too, I guess.
Absolutely. A teacher who seems annoyed or maybe rushed or just aloof, they're instantly introducing psychological noise into the system before they've even gotten to the main content.
So clarity and approachability, those are baseline requirements for the sender. Non-negotiable.
You could say that, yeah.
Which brings us naturally to the second element, the decoder, or the receiver,
Yeah.
the learner.
The target audience, yes.
What do they need to bring to the table for this communication system to actually work effectively?
Well, the decoder obviously needs to be an active participant, a good listener. But instructionally speaking, the real key is the psychological dimension.
Psychological how?
The decoder must be psychologically ready, meaning they have to be mature enough, developed enough for the specific task at hand.
This sounds like that readiness principle from psychology.
It's drawn directly from it, yeah. The readiness principle dictates that the learner has to be intellectually ready, physiologically ready, emotionally ready to receive whatever specific knowledge or skill is being transmitted.
So trying to teach, I don't know, advanced calculus to someone who hasn't mastered basic algebra.
It's a guaranteed systemic failure. The decoder isn't ready. The communication can't happen effectively no matter how good the sender is.
Okay. Sender, decoder. What's element number 3?
The third element is pretty straightforward, but absolutely foundational. The message itself.
The content.
The content, yeah. The information, the task, the knowledge, maybe an attitude or a value or a skill that's planned for the learner to acquire.
And what are the requirements for the message?
The source material we looked at really stresses 2 things here. The message must be correct, factually accurate,
Obviously.
and importantly, it must also be adequate.
Adequate meaning?
Meaning, it has to be complete enough for the purpose. A partially correct message, or an incomplete one, even if it's delivered perfectly by a great sender to a ready decoder. It still results in a flawed output from the system. The learning isn't complete or accurate.
Got it. incorrect, inadequate. Okay, fourth element.
Fourth is the channel, or the medium. This is simply the vehicle. It's anything that relays the message from the sender to the decoder.
So this could be lots of things.
Oh, huge range. It could be
Yeah.
as simple as speaking oral presentation or a written handout, even nonverbal cues like gestures or expressions.
Right.
Or it could be more technological channels like radio, television, films, computer software, online platforms, you name it.
And I guess the choice of channel is pretty important.
It's crucial. The selection of the channel is very intimately linked to the nature of the message itself and also the characteristics of the decoder, the learners. You wouldn't use, say, a purely audio channel to teach intricate visual design principles effectively.
Right. Makes sense. Okay, that's 4. What's number 5?
Number 5 is the element that really tells you if the whole process is working or not. Feedback.
Ah, feedback. We mentioned the sender needs to secure it.
Exactly. And it's often misinterpreted. People think it's just asking, any questions at the end.
Yeah.
But systematically, feedback is defined as the available facts that are collected specifically to determine the effectiveness of the communication attempt.
So it's data, essentially.
It's data. It's the essential mechanism for quality control within the system. It's what allows the sender, the teacher, to perform periodic assessments, maybe informal, maybe formal, and immediately fine-tune the process if the outcomes aren't matching the objectives.
And without that robust feedback loop.
The system is basically operating blind. You're just sending stuff out without knowing if it's being received as intended.
Okay. That leaves one element. Number 6.
And number 6 is the great spoiler, the systematic breakdown element. Noise. Noise is defined as anything, and it can be physical or abstract that makes it impossible, or at least difficult, for the decoder to get the message exactly as the encoder intended it.
And you said this is where it gets really interesting.
Yeah, because noise is often subtle. It's frequently invisible to the sender, who might think they're communicating perfectly clearly.
Okay, so we definitely need to break down these types of noise. Recognizing them seems like the first step towards, building that effective instructional blueprint.
Absolutely. If you don't know what can break the system, you can't design defenses against it. So we generally categorize noise into 3 strategic areas.
Okay, what's the first?
First is the most obvious kind, physical or environmental noise.
Like actual sounds.
Exactly. Disturbances coming from the physical surroundings, loud sounds from, say, a nearby market, construction noise like grinding machines, traffic outside the window.
Or even just the class next door being loud.
Oh yeah, definitely. An outcry from the next class. Poor acoustics in the room itself. Anything in the environment that physically impedes hearing or concentration. If the physical environment is hostile, the communication system just cannot sustain itself effectively.
Okay, that one seems fairly straightforward to identify, even if it's hard to fix sometimes.
True. But while a teacher might spot that external noise, they often miss the internal sources.
Internal. You mean inside the person.
Exactly. That brings us to the second category, physiological noise.
Physiological, meaning body-related.
Precisely. This stems from the ill health of either the sender or the receiver.
Ah, like being sick.
Yeah. A headache, a stomach disorder, chronic body pains, maybe even just being really tired or hungry.
Okay.
Imagine you're trying to absorb complex information during a lecture, but you're battling, say, severe dehydration or a migraine. Your physiological state is actively preventing that message from getting through properly. It's blocking the cognitive processing.
Right. Your body is basically screaming louder than the teacher's voice.
In a way, yes, it's creating internal static.
Okay, so physical noise from the environment, physiological noise from the body. What's the third category?
The third one, and I agree with you, I think this is often the most insidious and destructive in modern learning environments, is psychological noise.
Psychological. So mind-related.
Exactly. This is about an unfavorable state of mind. Things like fatigue, emotional depression, feeling annoyed, being anxious, or maybe just a generalized lack of enthusiasm or motivation for the topic.
And this can affect the decoder, the learner.
Profoundly.
Yeah.
If a learner is feeling anxious about an upcoming test, or bored by the subject, or upset about something unrelated that happened earlier, their mind isn't fully present or receptive. Psychological noise is clouding their ability to decode the message effectively.
And the source material made a really interesting point here. You touched on it earlier with the sender's attitude that psychological noise can also originate with the sender.
Absolutely critical point. Yes. If the teacher walks into the classroom feeling annoyed or maybe rushed after a difficult meeting or just mentally exhausted.
Their internal psychological noise immediately communicates a whole distracting, often negative subtext. Even if their words are fine, their tone, their body language, it compromises that warmth and clarity that the sender element requires. It puts the decoder on edge.
Wow. So the teacher's own mental state is a potential source of system noise.
Definitely. And we also have to account for other sender-side noises that are directly related to the instruction itself.
Like what?
Things like poor preparation.
Mm-hmm.
If the teacher hasn't really mastered the material, they might fumble, seem uncertain.
Which creates confusion.
Right. Or a lack of deep knowledge might lead them to make things unnecessarily complex rather than simplifying. Using the wrong media for the task is another one.
Okay.
Even disturbing mannerisms like constantly pacing, fidgeting with a pen, avoiding eye contact. These can pull the decoder's attention away from the message.
Or just inadequate mastery of the language being used. Using jargon the learners don't understand. Exactly. Any one of these sender-side issues can break the decoder's concentration, introduce noise, and render the intended message partially or wholly incoherent.
Okay, so we have the 6 essential components: sender, decoder, message, channel, feedback, noise. And we know noise can come in physical, physiological, and psychological forms from either side.
Mm-hmm.
Now, how do we visualize this whole process?
Right.
How does it flow?
Right. We need models for that. But first, it's useful to just briefly mention the different types of communication interaction based on who's involved.
Right.
You have intrapersonal communication, which is basically self-talk, thinking, processing internally. It actually precedes all other forms.
Right. You think before you speak.
Usually.
Hopefully.
Mm-hmm.
Then there's interpersonal communication, typically face-to-face between 2 people, maybe a few. It allows for very quick feedback.
Like a conversation.
Exactly. Then small group communication, which is often the scale of a typical classroom.
Mm-hmm.
More complex dynamics in interpersonal, but still allows for some interaction.
Then you scale up to public communication, like one speaker addressing a large audience, say in an auditorium. Feedback is much more limited there.
Right, maybe some applause or questions at the end.
And finally, mass communication using media like TV, radio, internet to reach a huge dispersed audience. Feedback there is very delayed and indirect, if it happens at all.
Okay, so different scales. Now the models. How do we picture the flow?
So models are basically our mental pictures, our diagrams of the process. The most foundational one, really simple, is Berlow's SMCR model.
SMCR.
Yeah, stands for Source, Message, Channel, Receiver.
Okay, source, message, channel, receiver. Very straightforward.
It's a fundamental linear representation, like a one-way street. Information flows from the source, through a channel, to the receiver. End of story. Think of that basic radio broadcast model.
Simple, but maybe too simple for teaching.
Often, yes, but it's the starting point. Then you have another well-known one, Lasswell's model.
Lasswell, how's it different?
Well, it's essentially the same linear system, SMCR, but Lasswell defined it by asking a series of critical questions.
Questions like?
Who? That's the source. Says what? That's the message. In which channel?
A channel.
To whom? The receiver. And crucially, with what effect?
With what effect? That adds the outcome, the purpose.
Exactly. It forces the designer or the communicator to explicitly think about the intention and the desired result of the communication. It maps directly onto Berlow's elements, but adds that layer of purpose.
Still linear, though. Who says what? Channel whom, effect. Still one way.
Still fundamentally linear, yes. But the real key, especially for instructional designers trying to build effective learning systems, is moving beyond linear models to the closed-loop model.
Closed loop, okay, sounds different.
It is fundamentally different because this model recognizes that communication, especially effective communication, is cyclical. It's not linear.
Cyclical how?
It recognizes that roles exchange constantly. The receiver doesn't just passively receive. When they transmit feedback, maybe a nod, a frown, a question, an answer, they instantly become the sender.
Okay. So the receiver sends information back.
Precisely. And the original sender then becomes the receiver of that feedback. It's an ongoing exchange, a loop.
That makes so much more intuitive sense for a classroom, doesn't it?
It's vital. That recognition of interactivity is crucial. If we treat teaching as a closed-loop process, the teacher can't just talk at the learners.
Right.
They have to consciously organize the entire process, the methods, the activities, to facilitate that role exchange, to encourage and capture that feedback.
And this is how you make sure everyone's on the same page.
Exactly.
Yeah.
This is how you establish and maintain what the source calls a common knowledge boundary, or sometimes a shared field of experience.
Field of experience, meaning what the learner already knows or understands.
Yeah. Their background, their prior knowledge, their vocabulary, their cultural context.
Hmm.
If the teacher is discussing, say, rocket science, they absolutely must use analogies, examples, simpler terms, maybe visual aids that fall within the learner's existing field of experience. Otherwise, the message, no matter how accurate, just sails right over their heads.
And the system breaks down. Communication fails.
The system breaks down. The loop is broken because there's no shared understanding, no common ground for the message to land on.
So a communication breakdown isn't always just, a technical glitch or someone not listening. It's often a failure by the sender to actively secure that feedback and ensure the message is actually landing within the learner's world.
That's a perfect summary of the implication. It's a design failure, often.
Wow. That's a really powerful insight as we move into thinking about the bigger picture of designing instruction. Okay, so if part one was drilling down into the kind of microscopic mechanics of how information gets transferred or doesn't, part two feels like we're zooming out. We're looking at the macroscopic structure, right? Building the entire learning environment intentionally.
Exactly. We're moving from the communication process itself to the framework for designing the whole instructional experience. And that takes us squarely into instructional systems development, or ISD.
ISD, right. But before we jump into the different ISD approaches, the source material spends some time defining what a system actually is. That terminology seems pretty foundational here.
It really is. You can't understand instructional systems design without grasping the concept of a system itself. So quite simply, a system is just a collection of elements or parts or components that all work together cooperatively towards achieving a single predetermined goal or set of goals.
Okay, parts working together for a goal.
Right. And the source emphasizes something important. The idea of a system is always relative. It depends on your frame of reference.
Relative how? Like a nesting doll.
That's a great analogy.
Right.
Yeah. Think of a country like Nigeria as the example used in the source. Nigeria is a massive, complex system in itself.
Right.
But at the same time, it operates as a subsystem within the larger supersystem of, say, the West African Economic Community or the African Union.
Oh, I see. So a system can be part of a bigger system.
Exactly. The parts interact within their system, but the whole system also interacts with its environment, its suprasystem. The key is that the internal parts must function jointly to serve the overall goal of their system.
Okay. So how does that apply to education? What's an instructional system?
An instructional system is simply taking that systematic viewpoint and applying it directly to education or training. It's a formal, structured way of planning, designing, implementing, and then evaluating the entire process of teaching and learning.
The whole thing, soup to nuts.
The whole thing, with the specific aim of producing desirable, predictable learning outcomes. It consciously integrates every single component we can think of.
Like the communication elements we just talked about.
Those, plus more. The objectives, the content or task, the teacher's role, the media chosen, the teaching methods used, the physical and psychological environment, and, critically, the learner, their characteristics, their readiness. All of it viewed as interconnected parts of one system.
Okay. So when a designer sets out to build one of these instructional systems, they have some choices to make up front, right? The source mentioned different ISD approaches based on who or what is actually doing the teaching.
That's right. Once you adopt the systems view, you need to make a strategic choice about how the instruction will primarily be delivered. Who or what carries the main instructional burden, and our sources highlight 4 distinct approaches based on that choice.
Okay, what's the first approach?
First is media-mediated instruction, or MMI.
Media-mediated. So
Yeah.
the media does the teaching.
Essentially, yes. Here, media things like computer software, interactive videos, sophisticated online modules, maybe even older programmed instruction texts, act as surrogates for the teacher. They handle the instruction either partially or sometimes totally.
Right, like a fully self-paced online course.
Exactly. That's a prime example of MMI. The strength there is usually consistency. Every learner gets the same core instruction and scalability. You can reach many learners.
What's the downside?
The potential weakness is often a lack of immediate, nuanced human feedback. The kind of adaptive interaction a live teacher can provide, it can feel impersonal or not cater to specific difficulties very well.
Okay. MMI, what's the second approach?
Second is probably the most traditional, teacher-mediated instruction, or TMI.
TMI. Teacher mediated. So the teacher is front and center.
Front and center, yeah. This is the classic teacher-centered approach. It usually relies heavily on methods like the straight lecture, maybe a structured demonstration.
A sage on the stage model.
Pretty much. It can be effective for large audiences, especially for just transmitting basic information efficiently, but it inherently risks breaking that closed-loop communication model we talked about.
How so? By limiting interactivity.
Exactly. The learners can easily become passive listeners, just receiving information. It can easily revert the communication back to that simple, linear SMCR framework.
Which, as we established, makes it highly susceptible to noise, makes it hard to check that common knowledge boundary, and doesn't guarantee engagement.
Precisely. So TMI has its place, but it carries those risks if not managed carefully with other techniques.
Okay. MMI, TMI, what's number 3?
Third, we have learner-mediated instruction, or LMI.
Learner-mediated, so the learners teach each other.
Essentially, yes. This is peer-mediated instruction. Students actively learn from and teach one another, usually working in small groups on a task or project.
Like group work.
Right. And this often yields really excellent results, particularly for developing deeper understanding and communication skills. Why? Because the participants, the students, often share a closer common knowledge boundary with each other than they might with the teacher. They speak the same language sometimes.
Makes sense. But I imagine it could get messy.
That's the big caveat the system warns about. LMI demands rigorous, meticulous, systematic planning by the teacher or designer.
Why?
Because without that clear structure, defined roles, specific tasks, and monitoring, the classroom can quickly descend into chaos. It can become just noisy, off-task, rowdy, and completely unconducive to achieving any learning goals. Structure is paramount for LMI.
Okay, so careful planning needed there. What's the fourth and final approach?
The fourth one is interesting and quite specific. Resource Person-Mediated Instruction, or RPMI.
Resource person, like bringing in a guest speaker.
Exactly. It involves bringing in a non-teaching expert, maybe a specialist engineer, a master craftsman, a local historian, a financial analyst, someone with deep practical knowledge in a specific area to handle a particular segment of the lesson or course.
Okay, so you leverage their expertise.
You utilize them for their unique knowledge and experience, but, and this is the crucial caveat highlighted in the source, the expert teacher must still guide that resource person.
Guide them on what? To the expert, right?
They're the subject matter expert, yes. But the professional teacher needs to guide them on the instructional aspects. The specific content to cover, relevant to the learner's level, the most appropriate method of delivery for this audience, and the best media to use to support their presentation.
Wait, why is that so critical? If they're brilliant, can't they figure out how to explain it?
Not necessarily from an instructional perspective. They are being utilized as an instructional resource, but they don't necessarily have the professional training of an educator.
Ah, I see.
That brilliant engineer might be tempted to use highly technical industry jargon that goes way over the heads of novice learners. They might default to a pure TMI lecture style that fails to engage the students. Or they might select overly complex visuals media that isn't appropriate for a foundational class.
So the teacher acts as a translator or a coach for the expert.
Exactly. The professional educator acts as the system's governor, in a way. They ensure the expert's valuable content is translated into the language, methodology, and media format that's actually appropriate and effective for the target audience and the learning objectives.
That makes perfect sense. So MMI, TMI, LMI, RPMI, those are the designer's broad choices for how instruction happens. But you said the success of any instructional system, regardless of which approach you pick, depends entirely on adhering to the underlying philosophy, the systems approach, or SA.
It's the bedrock, yes.
Why is this way of thinking, this systems approach, so essential for designing effective instruction, or really for solving any complex problem?
It's essential because it provides a structured, holistic way to think about and manage complexity. It rests on 6 core strategic principles. These aren't just nice ideas, they demand specific actions and considerations from the designer.
Okay, 6 principles. Let's walk through them. What's the first one?
1, the principle of wholeness. This is probably the most fundamental philosophical concept of systems thinking.
Wholeness, meaning?
Meaning, the entire system, the instructional program, the school, the training department, must be recognized and treated as an indivisible whole. You cannot effectively address or change parts in total isolation because everything is interconnected.
Okay. So practically, what does that mean for a designer?
Strategically, it means recognizing that if one part of the instructional system is weak or compromised, let's say,
Yeah.
funding for updated textbooks gets cut or teacher morale is low, it will inevitably affect every other part of the system.
Like ripples in a pond.
Exactly. It'll impact student engagement, the effectiveness of the methods used, maybe even the validity of assessment results.
Yeah.
So if you try to fix the curriculum but you completely ignore a toxic learning environment, you haven't addressed the whole problem, and your fix likely won't stick. You have to look at the entire system.
Right. Principle of wholeness. Got it. What's number 2?
2, the principle of systemization. This principle directly tackles disorganization and haphazard approaches.
Systemization. Sounds like being systematic.
It is. It mandates that planning must rigorously precede action. And this planning can't just be a vague, disorganized line of thought like, yeah, I think we'll do this.
No winging it.
Definitely no winging it. The planning must be based on concrete, collected data. It requires orderliness, clear sequences, and systematic documentation of the intended processes and goals. It's about deliberate, data-informed design versus improvisation.
Okay. Plan before acting, based on data. Principle number 3.
3, the principle of environmental compatibility. This reminds us that no instructional system exists in a vacuum.
Right. We talked about super systems earlier.
Exactly. Every instructional system operates within a larger environment, a super system. This could be the school district, the local community, the company culture, the national education policies. And the system relies heavily on this external environment for a sustained supply of energy and input. That could be funding, student enrollment, qualified teachers, political support, even just social acceptance.
So the system design needs to fit its environment.
It has to be compatible. A brilliantly designed program that completely ignores the cultural context of the community it serves or the resource limitations imposed by the school board is likely doomed to fail. It's not compatible with its environment, so the environment won't sustain it.
Okay. Environmental compatibility. Makes sense.
Yeah.
Number 4.
4, the principle of optimization. This goes beyond just being functional or efficient. It demands striving for maximum effectiveness.
Optimization. Getting the best possible performance.
Exactly. A system must be designed and managed so it can function at its full capacity to achieve its predetermined objectives. This requires ensuring that all the internal units or components, the staff, the learners, the administrators, the technology, are all functional and working to their highest potential.
Can you give an example?
Sure. Let's say you have a state-of-the-art computer lab, great hardware, great software. But if the internet connection is unreliable and fails 50% of the time, or the technician isn't available to fix problems quickly,
Then that unit isn't optimized.
precisely, that component isn't functioning at full capacity, and its failure drags down the potential effectiveness of the entire instructional system that relies on it. Optimization is about ensuring all parts are working as well as they possibly can.
Okay. Optimization. Principle number 5.
5, the principle of variety. This is about flexibility and having options.
Variety.
The instructional designer must always recognize and consider alternatives, varieties of ideas, different teaching techniques, different methods, different media options. You shouldn't get locked into just one way of doing things.
Why is variety so important?
Because you need to constantly seek the most relevant or the best choice among those available alternatives for your specific context, learners, and objectives. And also, variety provides strategic redundancy.
Redundancy meaning backup plans.
Kind of. If one method or medium fails to effectively reach a certain segment of your learners, you need to have an alternative approach built into your plan ready to deploy. Relying on a single pathway is brittle. Variety makes the system more robust and adaptable.
Okay. Principle of variety, have options. That leaves one more. Number 6.
And finally, 6, the principle of equifinality. This one is quite philosophical but has very practical implications.
Equifinality. Sounds complex.
It basically acknowledges that problem solving, especially in complex systems like education, is not a neat, tidy, finite project. It's a continuous, ongoing process.
No clear beginning and end.
There's often no absolute beginning and no absolute end. The system is dynamic, constantly changing, and crucially, solving one problem often invites or reveals another one.
Can you give an example of that?
Sure. Let's say you successfully address the problem of poor student test scores in math by implementing a new intensive tutoring program. That's great. But that solution might then create a new problem. Maybe it puts an unsustainable workload on the teachers, or it takes time away from other important subjects, leading to dips in performance there.
Okay. Fixing one thing affects something else.
Exactly. Equifinality means you need a continuous feedback loop, constant monitoring, and ongoing adjustment. The job of managing and improving the system is never truly done. It requires perpetual vigilance and adaptation.
That principle of equifinality really hammers home the dynamic nature of systems. If it's this continuous process, how do you actually structure the work? You mentioned the systems approach. SA is structured into two main parts.
Yes, to manage this complexity, essay is typically broken down into a two-part process: system analysis first, and then system synthesis.
Analysis, then synthesis. What happens in system analysis?
System analysis is where you do the deep diagnostic work. You're breaking the problem or the instructional need down into its constituent parts to really understand it. It involves identifying the core problem and then analyzing it thoroughly to set clear goals.
Okay. How do you analyze it?
This typically involves four key steps within the analysis phase. First is mission analysis. This is where you define the overall goal. What's the ultimate desired state of the learner or the organization after the instruction? What's the big picture mission?
Setting the ultimate target. Got it.
Second is functional analysis. Here, you start grouping the necessary functions or capabilities needed to achieve that mission. You break the mission down into major functional components, making sure the overall profile is logical and achievable, avoiding designing something impossible given the constraints.
Okay. Breaking the mission into functional blocks.
Third, and this is absolutely critical for instructional design, is task analysis.
Task analysis. We mentioned this briefly.
Right. Here, you drill down further. You identify a specific task needed to perform a function, and then you determine all the specific sub-skills, the sub-contents, the enabling knowledge required for a learner to successfully master that identified task.
So breaking the skill down into teachable chunks.
Exactly. Learning to, say, write a coherent essay isn't just one monolithic task. Task analysis breaks it down into things like understanding essay structure, mastering grammar and punctuation, developing research skills, formulating a logical argument, citing sources correctly, all the prerequisite pieces.
And task analysis also forces us to think about what kind of learning is needed, right? The domains.
Absolutely crucial point. Task analysis requires categorizing the required learning into the three major domains. Cognitive, that's intellectual knowledge, understanding concepts, problem solving; effective, dealing with attitudes, values, beliefs, motivation; and psychomotor, the development of physical skills, coordination, manipulation of objects.
So if you were designing, say, a first aid course,
You'd need task analysis to identify requirements in all three domains. Cognitive, understanding the steps for treating shock; psychomotor, correctly performing CPR compressions; effective, developing the confidence and willingness to actually intervene and help the victim. You have to plan for all three if the overall task requires them.
mission, functional, task analysis. What's the fourth step in analysis?
The final step in the analysis phase is method-means analysis. Now that you have a clear picture of the mission, functions, tasks, and learning domains involved, you start considering the alternative ways the methods and the means, like media or resources, you could use to achieve those learning requirements. You weigh the pros and cons based on the data gathered in the previous steps.
So you're exploring options before committing.
Exactly. You're doing your due diligence. Only after this rigorous four-step system analysis is complete do you move into the second major part: system synthesis.
And synthesis.
Synthesis is where you actually choose the best solution strategies from the alternatives you identified. You design the detailed instructional materials, you implement the plan, you execute the instruction, and then, critically, you evaluate the effectiveness of the total system in achieving the mission you defined way back in step one. Analysis is the planning, synthesis is the doing and checking.
Okay, this is great. We've laid out the theoretical foundation with communication processes and models, and then the overarching strategic framework of the systems approach in ISD. Now let's get really practical. Let's transition into the actual execution of the design, the key factors that an instructional designer needs to manipulate and control when they're building out the blueprint for a specific lesson or a course.
Right, we're moving from the why and the how of the overall process to the specific ingredients you need to manage within the instructional system itself.
So where do we start? What's the first key factor?
The first factor is naturally the task itself.
The task. We defined this earlier as what's being learned.
Exactly. It's the core content, the subject matter, the specific skills, or the knowledge that the learner is intended to acquire. Now, in most formal education settings, schools, universities, even corporate training, the task is often already conveniently prepackaged. It's usually found right there in the official curriculum guide, or the course syllabus, or the training manual. The designer's job typically isn't finding or inventing the task from scratch.
So what is their job regarding the task?
Their crucial job is to take that predefined task and subject it to that rigorous task analysis we just discussed in the systems approach. Breaking it down, identifying sub-skills, determining the learning domains involved, understanding the task deeply is step one.
Okay, so you analyze the task. What defines why we're doing this task?
That brings us to the next absolutely critical factor, the objectives.
Objectives, the learning goals.
Precisely. Objectives state the reasons why things are being embarked upon. They define the intended outcomes. Now, there are different levels of objectives, from broad aims to very specific ones. In ISD, we are intensely focused on specific, instructional, or most importantly, behavioral objectives.
Behavioral objectives. Why the emphasis on behavior?
Because they are the only type of objective that allows the system designer and the teacher and the learner to definitively measure whether the intended learning has actually occurred. They describe an observable behavior.
Right, not just understand or know, which are internal.
Exactly. Those are too vague for systematic design and evaluation. So the source material provides very rigorous criteria for how to state effective behavioral objectives. These aren't suggestions. They're seen as requirements for system quality.
Okay, what are these criteria? How do you write a good behavioral objective?
An objective must meet 5 key requirements. 1, it has to be stated in simple, clear, precise language, no ambiguity.
Okay, simple and precise.
2, it absolutely must use observable and measurable action words, verbs that describe something you can see or hear the learner do. Things like describe, list, calculate, demonstrate, compare, construct.
Not understand, appreciate, learn, no.
Exactly. Those describe internal states, not observable behaviors. 3, the objective must be learner-oriented. It has to focus on what the student will be able to do as a result of the instruction, not what the teacher plans to cover or present.
Big difference. Focus on the learner's performance.
Crucial difference. 4, a well-stated objective should ideally show the degree of performance expected, the standard of mastery.
Like how well they have to do it.
Exactly. For example, list the 5 elements without any mistake, or solve 9 out of 10 problems correctly, or type at 40 words per minute with no more than 2 errors. It sets a clear target.
Okay, specifies the standard. And the 5th criterion.
5, it should include a time element where appropriate. This could specify how long the learner has to perform the task within 5 minutes, or it might refer to the time frame of the lesson itself by the end of this 60-minute session.
So let's try an example. A bad objective might be, students will understand the closed-loop model of communication.
Right. Understand is internal, not observable, not measurable.
So a good behavioral objective, following those criteria, might be something like, by the end of the 20-minute discussion time element, the learner-oriented will be able to define observable action word, the functions of the encoder and the decoder in the closed-loop model, with 100% accuracy degree of performance using precise language inside clarity.
That is spot on. That's the structural difference between just having a vague intention and having a measurable outcome that you can design for and evaluate against. It drives the entire system design.
Okay, so analyze the task, define clear behavioral objectives. What's the next key factor the designer controls?
The next crucial factor is the factor of methods, teaching methods.
How the information is actually presented.
Exactly. Methods are the vehicles for presenting the information, for facilitating the learning activities, and the instructional designer absolutely must be deeply knowledgeable about pedagogy, about different teaching methodologies.
Why is that depth of knowledge so important?
Because choosing the wrong method for the task, the objective, or the learners, immediately introduces noise into the system. It prevents optimization. It can completely undermine the learning process, even if the content is perfect and the objectives are clear.
Okay, and methods are generally grouped into categories, right?
Yeah, the most common classification is teacher-centered versus learner-centered methods.
Teacher-centered being things like lectures.
Right. The traditional lecture, maybe a highly structured demonstration or a guided discussion where the teacher controls the flow tightly.
And learner-centered.
Learner-centered methods shift the focus to active student involvement. Things like role-playing, educational games, simulations, project-based learning, inquiry-based learning, micro-teaching sessions where students practice teaching each other.
So what are the trade-offs? When would a designer choose one over the other?
Well, teacher-centered methods, like the lecture, can be very efficient for delivering large amounts of foundational information to a big audience relatively quickly.
Okay, efficiency.
But As we discussed with TMI, they carry that significant risk of learner passivity and lack of engagement. Learner-centered methods, on the other hand, are fantastic for promoting deeper understanding, critical thinking, collaboration skills, and practical application. They foster that interactivity needed for the closed-loop model.
But they probably have downsides too.
They do. They generally demand much more planning time from the teacher, often require more resources like materials for projects or specific room setups, and they usually work best with smaller audience sizes. Trying to run a complex simulation with 200 students is challenging.
So the choice isn't automatic.
Not at all. The decision about which method, or more likely, which combination of methods to use, must depend entirely on a careful analysis of several factors: the nature of the task itself, the specific behavioral objectives, the characteristics of the learners, their age, prior knowledge, learning styles, the resources available, time, money, materials, space, the overall cost effectiveness, and the audience size.
And you gave the example earlier. If the objective involves a psychomotor skill, like learning to operate a piece of equipment,
Then, choosing a purely lecture method, teacher-centered cognitive focus, would be a catastrophic mismatch. You need hands-on practice, a learner-centered psychomotor-focused method. The method must align with the objective and the task.
okay, method selection is critical and context-dependent. What works hand in glove with method?
Complementing the method very closely is the factor of media selection, choosing the right tools and materials.
Media, like the channel and the communication model.
Exactly. Now, the source material here strongly emphasizes a critical system risk regarding media. No single medium can teach analytically.
Meaning you can't rely on just one tool.
Correct. A heavy reliance on only one medium, just textbooks, or just PowerPoint slides, or just videos, is considered a failure of that principle of variety we talked about in the systems approach.
So the designer needs to think multimedia.
They absolutely must adopt a systems view of media and prioritize multimedia utilization, using a variety of media strategically blended together.
Why is using multiple media so essential? Why isn't one good tool enough?
Because different media have different strengths and weaknesses. They are suited to different types of learning objectives, different types of content, and they even engage different parts of the brain.
Can you give an example of blending media?
Sure. You might combine, say, a short podcast segment or a radio broadcast, which is good for reaching people easily and telling stories, with supporting visual materials like posters or infographics, which are good for reinforcing key points and aiding visual recall.
Okay.
Or you might use real-life objects for hands-on exploration, supplemented with detailed photographs or diagrams for closer study. Or a computer simulation combined with a structured worksheet for reflection. The blend depends on the goal.
And what factors should guide the choice of specific media?
Several key factors. First, appropriateness to the chosen method. The media must support the teaching method, not fight it. You wouldn't typically show a long passive film strip if your method is supposed to be an active small group discussion.
Right. Alignment is key.
Alignment is key. Then, the quality of the media itself. Is it clear, accurate, engaging, well-produced? Quantity, do you have enough for all learners? Size, is it physically appropriate for the viewing distance or handling? Ease of use, can the teacher and learners actually operate it without excessive difficulty?
And importantly,
And critically, the learner's access to the media, is it readily available when needed? A fantastic online resource is useless if students lack reliable internet access outside of class. A sophisticated piece of lab equipment that breaks down frequently or is only available for use once a week becomes a systemic liability, not an asset. Access and reliability are crucial.
okay, task, objectives, methods, media. These seem like the core instructional components. What else does the designer need to manage within the system?
Moving beyond the immediate lesson structure, we absolutely must consider the physical and temporal constraints of the system, starting with the factor of space, the physical learning environment.
Space, you mean like the size of the classroom. How does that impact things?
Space is an essential, yet often completely ignored, instructional variable. The physical environment, the classroom, the lab, the workshop, must be adequate for the planned activities.
Adequate how?
It needs to be large enough to allow for free movement, especially if methods involve activity or group work. It has to comfortably accommodate the necessary activities and the furniture required, and fundamentally it needs to ensure learner comfort and focus.
And this connects back to those systems approach principles.
Directly back, it connects to environmental compatibility. Is the space suitable for the learning intended? And optimization is the space allowing the system to function effectively, or is it hindering it?
So why exactly does space matter so much instructionally?
Because an inadequate space, particularly an overcrowded classroom, actively inhibits the effective use of many valuable methods. It makes learner-mediated instruction, LMI, like small group work, almost impossible. It prevents independent study if there's no quiet corner. It makes practical, hands-on exercises difficult or unsafe.
And it introduces noise.
And it physically introduces noise, discomfort, and distraction. If the physical room actively restricts the teacher's ability to use the most appropriate method for the objective, then the entire instructional system is fundamentally failing right there. Space enables or disables methods.
Okay. Factor of space is crucial. What works hand in hand with space?
Time. The factor of time. How time is allocated and managed.
Right. Time determines the duration of the lesson, but also how much time is spent on each part.
Exactly. Effective time management in instructional design means carefully planning the duration allocated to every distinct segment of the learning experience. The introduction to gain attention and state objectives, the core delivery of information or skills, the time for learner involvement and practice, and the time for evaluation or checking understanding.
And precision here is important.
Precision is absolutely key. This requires the designer, or the teacher implementing the design, to create a realistic time budget for every major objective or activity.
Why is budgeting time so critical?
Because if the objective is complex, the system must allocate sufficient time for learners to process, practice, and internalize it. Rushing through complex objectives just to cover the material is another guaranteed failure point. It leads to superficial learning at best, or complete failure to achieve the objective, especially if all three domains, cognitive, affective, psychomotor, need to be addressed. Time is a finite resource that must be spent wisely according to the objectives.
Okay. Space and time are the physical and temporal containers. What's the final key factor for ensuring the system worked?
Finally, we arrive back at evaluation, but viewed now as a core design factor, the factor of evaluation. This is the ultimate feedback loop for the entire system.
We talked about feedback and communication, but this is broader.
Much broader. Evaluation in the ISD context is described as a value-laden concept. It's used to judge the effectiveness, the worth, the merit of the entire instructional system.
The entire system, yeah.
Meaning not just evaluating the learner's performance, but evaluating the teacher's effectiveness, the clarity and appropriateness of the objectives themselves, the suitability of the media and methods chosen, the adequacy of the learning environment, everything.
Wow. So its purpose is quality control for the whole design.
Exactly. Its primary purpose is systemic quality control. It aims to identify weaknesses anywhere in the system and, crucially, to provide the data needed for corrective measures. How can we improve the quality and the quantity of what is learned next time? It connects directly back to that need for feedback we established in Part 1, but on a macro level.
Okay. And just like with communication feedback, evaluation isn't just one thing. The source classifies it into two main types based on timing.
That's right. Two main systemic types. First is formative evaluation.
Formative, meaning it forms the instruction.
Kind of, yeah. It happens during the instruction process. It's designed to be continuous, systematic, and cumulative. Think of things like ongoing continuous assessment quizzes, homework checks, observing students during activities, asking quick checking for understanding questions, maybe short polls.
And what's the power of formative evaluation?
Its power lies in allowing the sender, the teacher or designer, to get feedback while the process is still underway. It allows you to fine-tune the instruction, to make mid-flight corrections before potential failure becomes systemic and widespread at the end. It informs adjustments in real time.
Okay. Formative is ongoing feedback during the process. What's the other type?
The second type is summative evaluation.
Summative, like a summary at the end.
Exactly. This is the more traditional one-shot assessment that's typically taken at the end of an instructional unit, a course, or a program. Think of final examinations, capstone projects, final performance reviews.
And its purpose?
Historically, this was often the main, sometimes only, way overall performance or learning was judged. It's essential for things like certification, grading, and making a final judgment about the overall success of the program or the learner's mastery.
But it has limitations compared to formative.
Its main limitation, from a systems improvement perspective, is that summative evaluation alone doesn't really allow for corrective measures within that specific learning process. It tells you how things ended up, but it's too late to fix problems for that cohort. It provides judgment on the final outcome.
So the best instructional systems probably use both.
Absolutely. The most robust instructional systems strategically utilize a blend of both formative evaluation for ongoing monitoring and adjustment and summative evaluation for final accountability and judgment. They work together.
And the ultimate goal, regardless of whether it's formative or summative evaluation, is always to determine if that intended behavioral modification, the system's ultimate objective defined way back at the start, actually occurred effectively and efficiently.
That is the bottom line. Did the system achieve its predetermined goals? Evaluation closes the loop. Hashtag outro.
Wow. This has been a really profound deep dive.
Yeah.
We started way down at the microscopic level looking at how communication can break down because of, psychological noise or maybe failing to establish that shared field of experience.
The nuts and bolts.
And we've zoomed all the way out to the macroscopic architecture of instructional systems development, the whole blueprint.
Yeah, from the atoms to the building.
The key takeaway, it seems, for you listening, especially if you design or deliver any kind of instruction, is that effective learning design is absolutely not accidental. It's not magic.
Definitely not magic. It's engineering.
It's a meticulously structured, systematic process, and its success depends entirely on rigorously applying these principles, things like wholeness, like variety, like optimization, across every single stage. From writing those measurable behavioral objectives right through to selecting the right blend of media methods, managing the time and space, and building an evaluation, success is engineered.
That's the core message. The ultimate objective is always to improve both the quality and the quantity of what is learned, reliably and predictably.
So we discussed those 6 principles of the systems approach: wholeness, systemization, environmental compatibility, optimization, variety, and equifinality.
The guiding philosophy.
And that last one, equifinality, it tells us that this work is never really done right. Problem solving is continuous. A successful system needs constant tending, as solving one problem often invites another.
The dynamic reality.
So here's a final thought for you to mull over, building on that. If all 6 of those principles are essential for the health and survival of an instructional system, which single principle, if you were forced to choose one that was utterly ignored or violated, do you think would cause the entire system, whether it's a university curriculum, a corporate training program, or a single K-12 classroom, to fail the fastest, and why?
Ooh, that's a tough one. Which pillar, if removed, makes the whole structure crumble quickest?
Exactly. Something for you to think about as you go about designing your next learning experience.